Hello everyone. In this video we will solve problems regarding Hess's law. When we say Hess's law, directly clicks into our mind the enthalpies. So for any reaction that can be written in a series of steps, the enthalpy change of the reaction will be the same as the sum of the enthalpy changes for the steps. Like here in this example that we will solve later on, this reaction, it happens in 3 steps. We will see how we will rearrange equations in a suitable way to give me this equation and to calculate its enthalpy, and it should be the summation of these steps after rearrangement. Okay, let us start by solving problems. In number 1, calculate delta H for this reaction, and these equations given to me with their data of enthalpy of change. Let us start. In the equation that I'm intending to calculate its delta H, as you can see, we have C2H4 in the reactant side, and here in the data also we have it in the reactant side. So simply I will rewrite it as it is, plus 3O2 gas to give me 2 CO2 gas plus 2 H2O liquid. Nothing happened to the enthalpy because I rewrote the equation as it is. C2, leave the hydrogen till the end. C2H6 in the product side. From the data, we have C2H6 in the reactant side, so we will flip it. So we will say that we are gonna flip equation number 2 such that products will be the reactants and the reactants will be the products. Why? Because I want C2H6 in the product side, plus 7/2 oxygen. Because I flipped it, simply the sign should be flipped, so instead of negative, it will be positive 1560 kilojoule per mole. Now hydrogen in the reactant, and from the data we have hydrogen also in the reactant side, so I will do nothing to it. Simply I will rewrite it, and delta H, it's the same because the equation was not subjected to any type of change. Now if I want to add these equations, should give me the equation that I'm looking for. It's delta H. C2H4, nothing to add or subtract from the product or the reactant, so I write it like this. 2 CO2 product, 2 CO2 reactants, so I subtract them, so they sum up to 0. Here we have 2 H2O and 1 H2O in the product, sum up to 3 H2O, and 3 H2O in the reactants, so they subtract each other. 3 oxygen and half, 3.5, here 3.5 in the product, so their subtraction sum up to 0, plus hydrogen, I write it, so plus H2 to give me C2H6. So the delta H for this reaction, according to Hess's law, simply the summation of the enthalpies, minus 1411 plus 1560 minus 285.8, and the answer minus 136.8 kilojoule per mole. Like this we solved number 1. Now let us move and solve number 2. Okay, in number 2, calculate delta H for this reaction. This time I have 4 ammonia plus 5 O2 to give 4 NO plus 6 water, and these are the equation data given to us. So from this equation, from the data given to us, I will calculate delta H by rearranging them such that to apply as usual Hess's law. So we will start. From the equation of my interest that I need to calculate its delta H, we can see that we have ammonia in the reactant side and the coefficient 4. Here from the data, ammonia in the product side with coefficient 2. So I will flip equation 2 and multiply by 2. So flip equation 2 and multiply by 2 as well. So it will be 4 ammonia in the gaseous state to give 2 nitrogen in the gaseous state plus 6 hydrogen in the gaseous state. Because I flipped it, the sign, it turns positive, and because I multiplied by 2, it will be multiplied by 2. So 2 times 91.8 kilojoule per mole. We have here oxygen, leave it till the end, it will be arranged by itself. We have here 4 nitrogen monoxide. From the data, nitrogen monoxide in the product, but it's not with coefficient 4, so I multiply equation 1 by 2. So we say multiply equation 1 by 2, so it will give me 2 nitrogen plus 2 oxygen gas to produce 4 nitrogen monoxide. Because I multiplied by 2, the delta H should be as well multiplied by 2. Now we have 6 molecules of water in the product side. From the data, we have 2 molecules of water in the product, so multiply equation 3 by 3 to get 6 water. But definitely I have, as usual, to multiply all the equations. So multiply equation 3 by 3. So it will be 6 hydrogen gas plus 3 oxygen gas to give me 6 molecules of water. Because I multiplied it by 3, delta H will be also multiplied by 3. So minus 3 into 8, 3.6. Now the summation of these should give me the equation, this one of my interest. I will prove it for you. For ammonia, nothing to cancel with or to add, so for ammonia. 2 nitrogen, and here 6 hydrogen, 6 hydrogen. Here we have 2 oxygen plus 3 oxygen, nothing to cancel from the product, so sum up to 5 oxygen. And here left with 4 NO, we write 4 NO and 6 water in the gaseous state, which is exactly the equation I'm looking for, its delta H. So according to Hess's law, delta H will be the summation of these delta H's. So it will be 2 into 91.8 minus 2 into 180.5, or plus minus, which is the same. Okay, plus 3 into minus 483.6, and the answer for sum up to 1 minus 1628.2 kilojoule per mole. Like this, we solved number 2. Now we will move into solving number 3. Still we are talking about Hess's law. Okay. In number 3, find delta H naught formation. So we want to find delta H naught formation, heat of formation for acetic acid using the following thermochemical data. Acetic acid, which is HC2H3O2. I want to find the heat of formation. Let us see how. For number 3. Okay. So for number 3, heat of formation, this is acetic acid, which is formation, it means that the acetic acid is formed in the product side. So HC2, H3O2, always the heat of formation, the product formed from its components. Hydrogen exists as H2 gas, carbon solid, C solid, and oxygen exists as O2 gas, and definitely it needs balancing. Here 4 oxygen, 4 hydrogen, 4 hydrogen, 2 carbon, so this should be multiplied by 2, and 2 oxygen, and for this equation I need to find its delta H. I need to find its delta H from the data given to me. I will continue with you from the data given to me. Okay, I have from the data. Okay, wait, because I want to make everything clear. Just give me 1 second, please. Okay, I will solve it down such that the answer will be clear for all of us. So in number 3, we have to find, as we said, delta H for the formation of acetic acid. Okay, acetic acid formed from its own components. Hydrogen exists as H2, carbon as carbon in the solid state, and oxygen as O2 in the gas state, but it needs balancing. This will be 2 hydrogen and this will be 2 carbon, and we have 2 oxygen, and for this one I need to find delta H. This is the data given to us that I will be using them. We want acetic acid in the product side. From the data we have it in the reactant side, so I will flip it. So 2 CO2 gas plus 2 H2O liquid to produce HC2H3O2 liquid plus 2 oxygen gas. Because I flipped it, its delta H value, it should be flipped the sign, flipping the sign. So instead of minus, I will put plus. So plus 875 kilojoule per mole. Okay. We want here carbon in the reactant side and with coefficient 2. Here I have it, but I have it with coefficient 1. So I multiply equation 2 by 2. So multiply equation 2 by 2. And the answer will be, and I will keep it in the reactant because we want the carbon already in the reactant side. So plus 2 oxygen gas to give CO2 gas. So because I multiplied it by 2, its enthalpy also should be multiplied by 2 times 2. Okay, now we want the hydrogen in the reactant side and with coefficient 2. So I will multiply equation 3 by 2. So multiply equation 3 by 2. So it turns to be 2 hydrogen gas plus 1 oxygen gas to give 2 H2O liquid, and its enthalpy as well should be multiplied by 2. Okay, now if I add these, should give me the equation of my interest that I'm looking to calculate its delta H according to Hess's law. I will show you, I will put it for you. Here we have let us see, here we have 2 hydrogen. Okay, nothing to add or subtract from these equations. This is the delta H that I need. I am looking at this equation, and this equation, and I'm adding them. So 2 hydrogen, nothing to add or subtract, so I write it as it is, 2 hydrogen. Here we have also 2 carbon, nothing to add or subtract, so I write it 2 carbon here. And here we have 2 H2O in the reactant and 2 H2O in the product. I cancel them. Here we have when I multiplied this by 2, this should be also multiplied by 2. So this is 2 CO2 and 2 CO2, they are cancelled with each other. 2 O2 and 2 O2 cancelled with each other. I am left with 1 oxygen, so I write 1 oxygen. Okay, to produce the acetic acid HC2H3O2. So simply delta H for this, it's the summation for these
delta H's. So upon adding these delta H's, the answer will be minus 485.62 kilojoule per mole. And like this, we solve according to Hess's law. Thank you for watching.